Now that we have reviewed synthetic division, we are going to look at something called the remainder theorem and see what else we can do with synthetic division, with polynomials, and zeros. So let's first begin by looking at 89/5 as a mixed number. So 89 divide by 5. Well, 5 goes into 8 once. And so that would be 1 times 5 is 5. Subtract. And then bring down the 9. And 5 goes into 39 7 times. And we get 35. We subtract and we get 4. And so we know that 89/5 is equal to 17 and 4/5. Or if we think about it as 17 plus 4/5, right? Because 17 and 4/5 is the same thing as 17 plus 4/5. So those two mean the same thing. Of course, we would never write a mixed number like this. We would only write it like this. So now, how can we use this to rewrite 89? Well, if we have 17 and 4/5 as a mixed number, how do we rewrite that as an improper fraction? We take the 5 times the 17 and add the 4. So 5 times 17 and add 4. And that would be all over 5. But we already know this is 89/5. So let's highlight the fact that 5 times 17 plus 4 is the same thing as 89. So 89 equals 5 times 17 and add 4. So notice this is the divisor times the quotient plus the remainder. So here we go. Let's do this now with a polynomial. This is the same thing. We can go ahead and divide. We'll do synthetic division this time. We can use our coefficients, 1, 4, -3, -12. We can bring down the 1, multiply, add, multiply, add, multiply, and add. So this means that if we rewrote this, we would have our original problems x cubed plus 4x squared minus 3x minus 12. And let's think about this as an improper fraction. This is over x minus 3. So this will equal the quotient, x squared plus 7x plus 18. That 42 is the remainder, so plus 42 over the remainder, or over the divisor, x minus 3. Now, if we think about this and we want to go backwards, we can take the divisor times the quotient plus the remainder. And so we would obtain x minus 3 times the quotient, x squared, plus 7x, plus 18, plus the remainder. And what's this equal to? This is equal to our x cubed plus 4x squared minus 3x minus 12. So we can always take our dividend and rewrite it by taking divisor times quotient plus remainder. So the division algorithm for polynomials is basically what we've been doing. If we have two polynomials divided, we can write that as the quotient plus the remainder over the divisor. And then we can go backwards and we can say divisor times the quotient plus the remainder is our dividend. So divisor times quotient plus remainder is our dividend. This and the next few exercises will help us see a connection between division and evaluating a polynomial. So let's do our synthetic division. 1 on the outside, and then our coefficients of our dividend are 1, -2, -11, +22. And so now, bring down the 1, then we'll multiply, add. So 1 times 1 is 1. And let's add, we get -1. Multiply, we get -1, and we can add. Multiply, and then add. And so our answer is x squared minus x minus 12 plus 10 over x minus 1. Likewise, we can do synthetic division on this. We have 5 on the outside. And then we have the same dividend as before. So 1, -2, -11, 22. So bring down the 1, multiply. 5 times 1 is 5. Add. Multiply 5 times 3, we get 15. Add. 5 times 4 is 20. And we get 42 for our remainder. So our answer is x squared plus 3x plus 4 plus 42 over x minus 5. So let's go ahead and evaluate our polynomial, which you'll notice this polynomial is the dividend that we've been seeing in the past examples. So we're going to take f of 1 and evaluate it. F of 1 will be 1 cubed minus 2 times 1 squared minus 11 times 1 plus 22. So we obtain 1 minus 2 minus 11 plus 22. And this yields for us 10. Now go ahead and pause the video and do part B and see what you obtain. Then I want you to make a connection between the answers from part A and part B to what we saw in our synthetic division problems. So let's go ahead and substitute 5 in for x. We obtain 5 cubed minus 2 times 5 squared minus 11 times 5 plus 22. So this is 125 minus 50 minus 55 plus 22, and this yields for us 42. Now, if you haven't done so yet, compare the 10 and the 42, the answers that we've obtained from evaluating our polynomial, to what we saw in the previous examples in synthetic division. What do you notice? 10 is the remainder from the example where we divided by x minus 1, and 42 is the remainder from whenever we divided by x minus 5. So there is a connection. If a polynomial function is divided by x minus c, then if you substitute c in for x, that's going to be the same as the remainder. So let's use that remainder theorem in this example. What is the remainder? So the goal is to find the remainder whenever we're dividing by x plus 1. So to determine the remainder, all we have to do, we don't have to go through the synthetic division. We can go ahead and substitute our value in, well, what's being subtracted from x? -1. So we'll substitute -1 in for x. So we'll have 3 times -1 cubed minus 7 times -1 squared minus 2 times negative 1 plus 8. So this is negative 3 minus 7 plus 2 plus 8, which equals 0. So now let's use synthetic division to rewrite this problem, just to see what the connection is. So negative 1 on the outside, and we have 3, negative 7, negative 2, positive 8. So bring down the 3, negative 3 when we multiply, then add, then multiply, and add, multiply, and add. So we do get that remainder of 0 like we had thought. But what else do we know? Let's rewrite our function f of x. So we know that our function will be the divisor, x plus 1, times the quotient, which is 3x squared minus 10x plus 8, plus the remainder. But notice, the remainder is 0. So we don't need to include that. What we've done is we have seen x plus 1 is a factor of our polynomial. And now, remind yourself what we've seen up to this point. Factors are related to zeros of functions. So we know that x plus 1 is a factor because negative 1 is a 0. And we can see that in the synthetic division because we obtained a remainder of 0. So remember that if we have a polynomial function, x minus c is a factor, if and only if, whenever we substitute c in, it zeroes out the function. In other words, x minus c is a factor, if and only if c is a 0. So to use the factor theorem here, what we can do is we can go, okay, what's being subtracted from x? And this would mean that c equals negative 4. So f of negative 4 equals the cube of negative 4 minus 3 times negative 4 minus 2. So we have negative 64 plus 12 minus 2, which is equal to negative 10. So negative 4 is not a 0, so x plus 4 is not a factor. So let's look now at our next example. So in part B, c equals 2. So f of 2 equals 2 cubed minus 3 times 2 minus 2. That gives us 8 minus 6 minus 2, which is 0. So since 2 is a 0, then x minus 2 is a factor.